In today's video, here is a nice number theory problem. It's coming from the Nordic Mathematics Olympiad, the year 1994. Here is the following information. Find all n as a positive integer, satisfy this following equation. So we get n is strictly inferior than 200. So we get this following equation. We get n square plus n plus number 1 square equals y square as a perfect square. Okay. So the trick of this problem, if you try to factor out this one on the form of the difference of the squares, it will not take you to the solution right away, okay? Because there is too many issues in this factorization. Now, you guys, you can give the hints to this problem pre-grade solution. Go ahead, pause this video when you come back to see the full solution. So let's distribute this one first. So we get n squared plus n squared, which is 2 times n squared. Then plus 2 times n plus number 1, which equals y square. Okay, so notice here, if I'm going to complete the perfect square here, but this is not enough because we get the coefficient 2, we need the coefficient 4 in order to make the perfect square here. What to do? We are going to multiply both sides by number. So we will have the following expression. So we get 4n squared plus 4n plus number 2 here, which equals twice is multiplied by y square. Now it's more clear to we have a perfect square here. So we get 2n plus number 1 quinary square plus number 1, which equals twice y square. Now let's put a nice substitution here. So let's set x equals 2n plus number 1. Then I'm going to move over this term to the left and move over number 1 to the right side. So I get the following equation. So we get x squared minus twice is multiplied by y squared, which equals minus number 1. So this is definitely is a Pell's equation. Pell's equation, it's normally is written on the form of 2x squared minus d y squared, which equals 1. So the general solution of this one, x0 plus y0 is multiplied by square root of 2 all to the n as an exponent. What is the n? Is a some integer, okay? x0 and y0, first obvious solution, okay? Now let's give the general solution of this one. But remember, we have minus number 1 here, we get the number 1 here, okay? So the obvious solution of this one, which is x0 equals 1 and y0 equals 1. If I'm going to replace that here, so I get 1 minus 2, which is minus number 1, which is verifying this equation. So the general solution of this one by recursion, so I get alpha n, which equals 1 plus square root of 2 all to the 2n plus number 1 plus or minus, depends the sign of this one, okay? But here the problem, the solution of this one is going to be written on the form of the odd exponent, not even exponent, due to the characteristic of this equation, okay? If you replace n with 0, it gets you to this solution, okay? If you replace n with number 1, it gets you to the different solution, which is verify this equation. But if you have the even exponent, never ever give you the solution of this one, okay? Always check the obvious solution for this one to give you the general image of the solution, okay? So be careful here. Also we get n, it gives us a positive integer, but we can include the n equals 0 as well if we want, okay? Since we get n equals 0 is a perfect square, we are going to eliminate this one. Let's put this one as non-negative integers to include this solution, okay? Let's expand this one out. So we get alpha n, which equals by the binomial expansion. So we get, so are taking only the positive solution. So we get 1 plus square root of 2 factor 1 plus square root of 2 square all to the n, okay? This one is definitely is going to give us 1 plus square root of 2 factor, we get here is going to give us 3 plus 2 square root of 2 all to the n. Let's replace it with this m. We are going to replace this one with m and set m. We are going to replace n with m. not make us mix with this one, because this one is different, this one is different. Okay, so let's put this one alpha m. Now we are going to expand this one, so we get a general solution alpha m, which equals 1 plus square root of 2 factor. This one is going to give us 3 to the m plus 3 to the m minus number 1 is multiplied by 2 square root of 2 is multiplied, which equals, I'm going to distribute this one out, is going to give us 3 to the m plus 3 to the m minus number 1 is multiplied by 2 is multiplied by square root of 2. Square root of 2 is multiplied by square root of 2, which is 2, is multiplied by 2, which is 4. Remember here, if you replace m with number 4, we get 4 choose 1, which is 4, is multiplied by 4, which is 16. 16 is going to multiply by 27, is going to give us something above 400. Then plus this term is going to give us something is bigger than 401. So which means this one will be greater than 401, which is impossible, which means the solution that we are going to tick must be belongs to this set 0 and 1 and 2 and 3 only. Okay, you are making the comparison between this term and this term, because this term is going to be written on this form, because x is representing this term is written on in terms of n, which is required to calculate. Okay, now let's get rid of this one and take the necessary solution for this equation. Because since we get a obvious solution x0 and y0 equals 1 and 1, so which means alpha 1 is going to be written, alpha 0 is going to be written on the form of 1 plus square root of 2. Okay, so the general solution of this one alpha m, which equals 1 plus square root of 2 all to the 2m plus number 1. Then we have determined m equals 0 and 1 and 2 and 3 only. Okay, so replacing m with 0, we get the first obvious solution, which is x0 equals 1 and y0 equals 1. Okay, thus we are taking x0 equals 1 here, so which means x equals 1 implies n equals 0. Okay, so get n equals 0 is a solution. Let's move on to the second solution. If m equals 1, we get the following solution. We get alpha 1, which equals 1 plus square root of 2. Replacing m with number 1, I get to the 3 here. So this one is definitely is going to be, this one square is multiplied by 1 plus square root of 2, which is 3 plus 2 square root of 2 is multiplied by 1 plus square root of 2. Let's distribute this one out. It give us 3 plus this term 2 is square root of 2 is multiplied by square root of 2, which is 2 is multiplied by which is 4. 4 plus 3, which is 7. So we get the 7 here. So we get 3 is multiplied by square root of 2 plus 2 square root of 5, which is 5 square root of 2. So here is the another solution. So the solution of this one, which is x1 equals 7 and y1 equals 5. We are taking only this one. So which means x equals 2n plus 1, which equals 7, which means n equals 3. Okay, so we get another solution, n equals 3. You guys are going to do the same thing. I'm not going to calculate the others due to the Lara calculation. So what will we find? We will find n, replacing m with 2 and 3. We will find n equals 20 and n equals 119. Okay, it's more simple. So I have done this problem. Thank you for watching. I will see you next video. Bye.